Hi, everyone, and welcome to the Solid Waste Authority of Palm Beach County's virtual programs. My name is Mary, and I'm one of the education specialists. Today, we have Kyle, the operations manager for Renewable Energy Facility 2, joining us again to take us behind the scenes. Occasionally, we shut down Renewable Energy Facility 2 to perform routine maintenance. This is to ensure that everything's working properly so we can continue to burn waste efficiently. If you tuned in last week, you got to see inside our boilers during one of these shutdowns. This week, Kyle's going to show us other parts of the facility. The videos today are going to show really unique vantage points inside our operations. So I really hope you enjoy watching. And if you have any questions during the video, please post them in the comment section below, or you can send us an email at education@swa.org. Also, in the comment section below, let us know where you're watching from. We love seeing that. And we also like hearing that you like what you're watching. So turn it over to you now, Kyle. It's all yours.
Hi guys, Kyle here again. It's part 2 maintenance here for our boiler outages. So we talked about all the boiler side of the equipment last week. So this week we'll talk about some of the other equipment, some of our environmental equipment or the other parts of the plant that we need to keep running. So right now I'm just standing in the warehouse. If you guys look behind me, we have a fully staffed warehouse, fully stocked with all of the components we would need to repair everything here. So that gives us the ability to have high reliability in case something were to go down unexpected. We have parts here that we can fix it, and also keep the parts that we can use preemptively, changing them before they fail, known based on expected life cycle of equipment to make sure that we try to avoid failures if all possible. So we'll go through that. We'll look at some of the equipment like a UT meter, and I can show you guys how we use that so we can check the thickness on the pressure parts to make sure that the metal is thick enough to hold the pressure without blowing. And we can even look at some of the catalysts. We pull some samples and we send them back to the manufacturer for them to be tested. So that's a good opportunity to see what that looks like. All right, guys, Kyle here again. We're going to talk about our catalyst today. So inside of our boiler, to deal with nitric oxides emissions, we have something called a catalyst. So the flue gas mixed with some ammonia goes through this. If you can picture these things standing upright, taking up the full flue gas path, so all of the gases have to go through this honeycomb, go all the way through, giving it the time to have the chemical reaction. So the ammonia, the nitrogen oxide, and this metal made out of vanadium breaks that apart, and we end up with nitrogen and water vapor. Those are both commonly occurring natural elements that are not harmful, and it allows us to remove the nitrogen oxides that would be harmful to the environment. So this particular piece of equipment here is what allows us to have emissions that are better than any other waste energy plant in the country. And to keep sure that this is working well, they take samples out during outages and they'll send it back to the manufacturer. They can do some chemical analysis and give us an understanding of how much life it has left until we have to replace it.
All right, guys, we talked in the past about our bag house, our fabric filter, so we can get a good view here. If we look up, we can see all of those bags that we talked about. So 1,700 plus bags total, and you can see the bottom of each one, and those hang down from the top. So the ash goes on the outside, the clean air goes through the center, and that goes out next to our stack. As our differential pressure increases, these bags get dirty. We can initiate some automatic cleans, so we'll blow some air from the inside, which kind of puffs that bag out, knocks the ash down into here, which is our hopper, which then gets added to our ash system. And that's how we take all the particulate out of there before it leaves through our stack. All right, another thing we can look at here when we're doing our maintenance, we check out all of our ash system, our conveyors. So this is a screw conveyor. If we look back over here, here's the bottom, one of the hoppers from the fabric filter units we were just looking at. And as we follow that ash, it comes into this screw. This screw pushes that ash along, eventually to this downchute where it goes into another conveyor. And we use a series of conveyors that take it to our ash house where we then do some more final sorting of that ash before we send it to our landfill. Now, as you see, we've got a screw from that hopper coming this direction to the center and a screw from this hopper coming to the center, and they both feed this downchute into our drag conveyor, which is a different type I'll show you shortly. All right, guys, so here's a different style conveyor. This is called the drag conveyor. So as you can see, there's a chain here in front of us, which has some paddles or flights. Those flights drag along the bottom, as you can see here. And any ash that's built up will get pulled along, dragged across the bottom, and eventually this chain will flip itself over, head all the way back to the front end of the conveyor, and start this process all over. So as it drags, it finally, when there's an opening, a hole in the bottom, the ash will fall down through a drop chute. So this is the other type of ash conveyors we use. We've got screw conveyors and flight drag conveyors.
Just wanted to show one of the tools we use. I talked about for outages. We do a lot of cleaning and inspections, and based on those inspections, we could have different work scopes we need to do. Part of those inspections is for us to look at the different parts of the boiler, especially the boiler tubes, and see how thick they are. So as that boiler tube gets worn down, it gets thinner and thinner from corrosion and erosion. Eventually, if it gets too thin, the pressure inside from the steam will make it explode. So to avoid that, we do some inspection. But obviously, you can't see through the metal. So we use something called an ultrasonic meter, or a UT meter. This allows us to do ultrasonic testing so we can see the thickness in a numerical value to know how thick the metal is without having to cut it. So we can do a little demonstration here. If you want to kind of zoom in here, you can see this is telling us basically in inches how thick something is. And we have a known block here, so we know that this is 1/4 inch and this is 1/2 inch, 3/4 inch, and 1 inch. And we can use this to verify that this meter is reading correctly, and then we can go in the field, put this on a tube, and know how thick it is. So if we take this and we put it here, we should be seeing 0.25, so we're very close there. And if we check over here, we should be seeing 0.75, and again, we're very close. All right, so this is just one of the tools that we use during our outages to keep the reliability of the boilers high.
All right, so we have completed our work scope for this boiler. So now we've gone in, we've pulled all the scaffolds. All of the people who were working have pulled their locks, allowing us to start this boiler up. Everything has been closed up. All the inspections are done. Make sure everything is clear and ready for operation. And so we've just inserted gas guns. So if you look through this viewport, we can see some of our gas guns. You can see the fire there. So we are inserting some natural gas, and we're using that to heat our boiler up. As you can see, you can look down in there. You can see kind of the grate system. Everything is empty. And what we're doing is we're warming this up like an oven, and we're getting it hot enough inside so that when we are ready to, we can drop trash in, and the heat will ignite that garbage. And then from that point on, the heat that's produced from burning trash becomes a self-sustaining fire. So we can take these gas guns out. We no longer need natural gas. So we need to warm these boilers up at a relatively slow rate, about 100 degrees an hour. And we do that to make sure that the metal doesn't expand too quickly. As we add heat, these boilers will actually grow in length about 18 inches. And if we did that too quickly, we would risk cracking them. So, anyways, here we go, starting the boiler up. So sometime this afternoon, we'll take these gas guns out after we put trash in there, and this will become a self-sustaining fire. And we'll keep this boiler online for approximately 6 months, burning garbage and making electricity.
Thank you again for watching, and really hope you enjoyed seeing those incredible videos around our Renewable Energy Facility 2 during a shutdown. If you're interested in checking out the rest of this week's educational programs, or may have missed some videos, you can check our Facebook or our website at swa.org/education. Have a great day.